Okay, let us now discuss question number 31 and 32 from the practice sheet. So, question number 31 says, John started work in 1995 at an annual salary of rupees 5,000 and received an increment of rupees 200 each year. In which year did his income reach 7,000? Okay. So it says that in 1995 John started working at a salary of rupees 5,000. His annual salary is rupees 5,000. So in 1995, if I talk about in 1995, question number 31st, in 1995 he would have received, or he has received 5,000 rupees as the annual salary. After that it says, and he received an increment of rupees 200 each year. For the each next year, he will going to have an increment of rupees 200 in his annual salary. And we need to calculate in which year his income will reach 7,000 rupees. In which year he will finally get 7,000 rupees annually. So, if I talk about his salary in 1995, it is 5,000. And if I talk about his salary in 1996, then his salary will become 200 rupees more than this 5,000, and it will become 5,200. Okay. If I talk about in 1997, his salary would again grow by rupees 200 annually, and he will receive a sum of 5,400 rupees in 1997, and so on. After this, even in 1998, in 1999, and so on, he will receive an annual increment. So this year will also increase, his salary will also increase, and in some nth year, he will going to have annual salary of rupees 7,000. So I need to determine in which year he will receive 7,000 rupees annually. From which year he will start receiving 7,000 rupees annually. So what I can observe is there is a pattern in his salary. The amount he is receiving annually, there is a pattern in that amount, and the pattern is that every year the salary is growing by rupees 200. It means if I talk about the difference between the salary of two consecutive years, the difference is a constant that is equal to 200 rupees. Here it is 200, and so on 200, then 200, and so on. So what I can say is that the annual salary of John is in arithmetic progression. It is continuously increasing, and by a difference of rupees 200. So I can say his salary is started from rupees 5,000. So if I talk about this annual salary, it is an arithmetic progression in which this 5,000 is the first term of this arithmetic progression, and the common difference in this arithmetic progression is rupees 200. So common difference is 200 and the first term is 5,000. And what I want to calculate in which year the salary is 7,000. So let us say it is in nth year, and let us say this is the nth term. Okay, this is the nth term of his working. Okay, of this series, of this arithmetic progression. Now my task is to calculate which term is this 7,000. Okay, my task is which term is 7,000. That is, I need to calculate the position of this 7,000. So let us say it is nth term. Let us say it is nth term. So for nth term, I know the formula, that is Tn is equals to a plus n minus 1 into d, where Tn is given as 7,000. So in place of Tn, I can write 7,000 is equals to a, that is 5,000 plus n minus 1 into 200, because the common difference is 200. So by solving this, 7,000 minus 5,000 will give you 2,000. and 2000 upon 200 is equals to n minus 1. So when you solve this, it will be 10 and n will be equals to 11. Okay, n will be equals to 11. So if n is equals to 11, does it mean that he will receive the salary of 7,000 in 2011 or 3011 or somewhere else? No, it do not mean that. Okay, why? It's because this series starts from 1995. The first term of this series lie in 1995, second term lie in 1996, third term in 1997 and so on. So in this manner, this 11th term should lie in which year? If I ask you, in this 11th term should lie in which year? So how will you deduce the 11th year? Okay, the 11th term starting from 1995. Just simply add 11 to 1995. Okay, simply add 11 to 1995. But remember one thing, I am calculating from 1995. So the years will be in this manner. First is 1995, then 1996, then 1997, 1998, 1999. So 2000, 2001, 2002, 2003 and 2004. So just calculate how many years are these. This is first year, second year, third year, fourth, fifth, sixth, seventh, eighth, ninth, 10th and one more year, 5. This is the 11th year. Okay, why it is happening? Because if you add 11 to 1995, if you add 11 to 1995, it will become 2006. So should I say that John will receive 7,000 rupees in 2006? No, it's not like that. It's because I am also calculating 1995. In 1995 also he is receiving a sum of 5,000 rupees because his job started from 1995. So 1995 is also one of the year that we need to take in consideration. Okay, so this will be the first year, this will be the second year. So if I say from 1995 to 1996, it will be 1 year. But in which year John started working? In 1995. So till 1996, how many years of job he has completed? In 1996, he has completed 2 years of job. At the end of 1996, he would have completed 2 years of job. In 1997, he would have completed 3 years of job. And in this manner, in 2005, he would have completed 11 years of job and he will receive an annual payment of 7,000 rupees. Okay. So the answer for this question is 2005 year. In 2005, he will receive a sum of rupees 7,000 as his annual salary. Okay. So this is the solution for question number 31. Okay, so let us now solve question number 32 from the practice sheet. Question number 32 says, Ram saved rupees 5 in the first week of a year and then increased her weekly savings by rupees 1.75. If in the nth week her weekly savings become rupees 20.75, then find n. Okay, so this question is almost similar to question number 31. This question is similar. Now one thing you can see is, you can also calculate this 2005 year by taking this AP, this considering this AP also. This is 1995, this is 1996, this is 1997. So what is the difference between these years? The consecutive terms, the difference between these years is 1. Okay, every time I am adding 1 to get the next year. So I can calculate the 11th term of this series also, of this AP also. Okay, how I can calculate? I can see that 1995 is the first year, so I can write A is equals to 1995, common difference D is equals to 1. So 11th year, that is T11, will be 1995 plus 11 minus 1 into 1. So this will give you 1995 plus 10, this will give you 2005. Okay, so 2005 is the year which is the 11th year of his job in office. Okay. So the 32 question, question number 32, it says Ram started saving rupees 5 from the first week of the year. So in the first week his savings was rupees 5. In the second week his savings was the savings will increase by an amount of rupees 1.75 and the savings will become 6.75, okay, 5 and 6.75. Then in the next year, that is the third year, his savings will become, in the third year, again I will add 1.75 rupees to his savings. Now add 1.75 to this 6.75. 0.75 is 1.5. 1.5 plus 1 is 2.5. 2.5 plus 6 is 8.5. So this will give you 8.5. Okay, you can calculate this orally. Do not calculate it in the rough sheet. Do not add it like what you have done in the first or second classes. Okay, so it says if in the nth week her weekly savings become 20.75, it means his savings will continue to some year, we don't know, to some week, we don't know which week, but we know that his savings one day will become 20.75. In some week in the future, his income, his savings will become 20.75. We need to calculate in which week his income will become, his savings will become 20.75. So what I can see, there is a pattern is in his savings. His savings is following the pattern of an arithmetic progression, because every time the savings is increasing by 1.75 rupees. Okay, so his savings started from rupees 5. So I will say the first term of this arithmetic progression is 5, and his savings is increasing by 1.75. The common difference for this arithmetic progression will be 1.75. And let us say in nth week his savings become, or his savings is equals to 20.75. So I am saying that Tn is equals to 20.75. Tn, now let us apply the formula for general term of an AP. Tn, that is 20.75, is equals to A, that is 5, plus n minus 1 into D is 1.75. Okay, it is 1.75. So solving this, 5 will come from RHS to LHS and it will become 15.75 divided by 1.75 is equals to n minus 1. So point will get cancelled. Let us divide this. If you cancel it using, let us say 75. So 75 2s are 150 and it will be, so no, it will not get cancelled. Let us calculate it by, so this is point, yes, so point is removed. So 75 2s are 150 and it will become 75 1s are 75. Now can I cancel this using 75? No, it cannot be cancelled. So let us cancel it by 25. So 25 6s are 150, 25 3s are 75, then 25 7s are, okay, 25 7s are and 7 1s are and 7 9s are. So this is what you will get. So 9 and this is 7. So 9 is equals to n minus 1, which implies n is equals to 10. So this is the simple calculation for this question. It's not at all difficult question. What it is getting is that n is equals to 10. It means in the 10th week, his savings will be 20.75 rupees. Okay. In the 10th week he will be able to save 20.75 because he is increasing his saving in arithmetic progression. So what you can see is that he can calculate in which week his savings will be 20.75 starting from the first week. Okay, he can calculate it very easily. He do not require to write each and every week's the savings of each and every week. He can just calculate, if I save 5 rupees today and increase my savings by 1.75 rupees every week, then in 10th week I will going to save 20.75 rupees. Okay, in this manner he can calculate his savings. So this is the solution for question number 32. Okay, so first note this, then we will continue. Okay, let us now discuss the next concept in arithmetic progression. We have discussed the concept of arithmetic progression, the pattern of arithmetic progression, and also the general term of an arithmetic progression. Okay, and we have also seen the practical importance of this derivations and this concept. Okay, now let us learn the next concept which is also of a practical importance, that is concept of sum of an AP. Okay, the concept of sum of an AP. What is meant by sum? Sum means addition, sum means add kar dena. Okay, if I say that, if I ask you what is the sum of first 5 natural numbers. If I ask you what is the sum of first 5 natural numbers. So what are natural numbers? Natural numbers are counting numbers which will start from 1. So first 5 natural numbers are 1, 2, 3, 4 and 5. Okay, you can see these 5 numbers are in arithmetic progression. The common difference is equal to 1 for this arithmetic progression. And if I ask you the sum of these 5 natural numbers, what you will going to do is you will going to add these 5 numbers. So 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15. So by adding these numbers, you will say the sum is equal to 15. Okay, so this is a very basic calculation. You have done this calculation many times and it's very easy. If I ask you what is the sum of an AP, if I ask you that there is an AP, let us say 15, then let us say it is 21, 27, 33, 39 and so on. If I ask you what is the sum of 5 terms of this AP, okay, if I ask you what is the sum of 5 terms of an AP, what you will do? You will add 15, 21, 15 plus 21, then 27, then 33, then 39 and so on, and you will add these and you will get the sum of these 5 terms of this arithmetic progression. But since here we have only 5 natural numbers, here I am asking you just to determine the sum of 5 numbers, the 5 terms of an arithmetic progression. But if I ask you what is the sum of first 100 natural numbers, if I ask you what is the sum of first 100 natural numbers, so are you going to add all the first 100 natural numbers, that is starting from 1 to 100, are you going to write it like this, 1 plus 2 plus 3 plus 4 plus and so on till 100, and you will add 1 plus 2 3, 3 plus 3 6, 6 plus 4 10, 10 plus 5 15, 15 plus 6 21 and so on. Are you going to do like this? No, you cannot do this, you will not be able to do this because it's very very frustrating. ये बहुत लंबा एडिशन है, मैं एक साथ बैठ के शुरू के 100 नंबरों को ऐड कर रहा हूं. इट इज नॉट मोर देन अ टाइम वेस्टिंग. ओके, ये कॉन्सेप्ट 100 टर्म्स को ऐड कर देना, आप लिख के 100 टर्म्स को ऐड कर रहे हैं, दिस इज a work of a second class student who do not understand the concept of arithmetic progression. Okay, so इस तरह की प्रॉब्लम्स 100 टर्म्स को ऐड करना एक बार में, इस तरह के प्रॉब्लम्स को सॉल्व करने के लिए हम अरिथमेटिक प्रोग्रेशन का सहारा लेते हैं, अरिथमेटिक प्रोग्रेशन के कॉन्सेप्ट को यूज करते हैं. नाउ अब ये कॉन्सेप्ट आया कहां से? अभी तो ये कैलकुलेशन 100 टर्म्स का दिया, तो आप कहेंगे कैलकुलेटर से ऐड कर लेते हैं. फिर मैंने कहा कि नहीं, अब फर्स्ट 1000 टर्म्स का सम निकालो. तो क्या आप 1000 तक के सारे नंबरों को ऐड करेंगे? नहीं, ऐसा नहीं करेंगे. तो फिर हम क्या करेंगे? हम यूज करेंगे एक कॉन्सेप्ट जो कि दिया था एक बहुत बड़े मैथमेटिशियन ने, जिनका नाम था गॉस. गॉस नाम के एक मैथमेटिशियन थे, एक साइंटिस्ट थे. इन्होंने फिजिक्स और मैथमेटिक्स की फील्ड में काफी रिसर्च की थी और काफी सारे लॉज भी बनाए थे. जब आप 12th क्लास में जाएंगे, इन 12th क्लास इफ यू टेक फिजिक्स एज अ सब्जेक्ट, then you will study that in electrostatics chapter there are some laws given by this great mathematician. So इन्होंने क्या किया था, and he done this concept when he was just 10 years old. सिर्फ 10 साल की उम्र में ही इन्होंने इतना बड़ा एक कॉन्सेप्ट दिया था, जिसकी वजह से आज हमारे बहुत सारे प्रैक्टिकल प्रॉब्लम्स सॉल्व होते हैं. ओके, इस गॉस के बारे में हम समझते हैं. गॉस ने क्या किया था? गॉस की क्लास में टीचर थे और टीचर बैठे थे और गॉस एज ए स्टूडेंट उस क्लास में बैठे थे. वहां पर बच्चे शोर कर रहे थे. ओके, दे वर शाउटिंग इन द क्लास. सो टीचर को डिस्टर्बेंस हो रहा था. सो व्हाट टीचर डिड, टीचर ने उन्हें एक असाइनमेंट दिया, पूरी क्लास को एक असाइनमेंट दिया, दैट ऐड फर्स्ट 100 नेचुरल नंबर्स. टीचर ने सभी स्टूडेंट से कहा कि आप शुरू के 100 नंबर्स का सम करके बताइए. और टीचर ने सोचा कि ठीक है, अब मैंने 1 से लेके 100 तक का एडिशन दे दिया सभी को, अब सभी बच्चे बिजी हो जाएंगे, सभी बच्चे कैलकुलेशन करेंगे. तब क्या हुआ, जैसे ही टीचर ने ये क्वेश्चन पूरी क्लास में दिया, विद इन 5 मिनट्स गॉस ने इसका सॉल्यूशन निकाल के टीचर को दे दिया. ओके, गॉस ने क्या करा, विद इन 5 मिनट्स 1 से लेके 100 तक नेचुरल नंबर्स को ऐड कर दिया. क्या वो उन्होंने एडिशन इसीलिए कर दिया बिकॉज उनका कैलकुलेशन पे बहुत अच्छा कमांड है, या फिर कुछ और कॉन्सेप्ट लगाया? हम उसे ही समझते हैं. देखिए, गॉस ने क्या करा, गॉस ने कहा कि लेट अस से लेट सम ऑफ फर्स्ट 100 natural numbers is capital S. ओके, गॉस ने बिल्कुल सिंपल सा कॉन्सेप्ट लगाया. गॉस ने कहा कि लेट अस से कि फर्स्ट 100 नेचुरल नंबर्स का सम कितना है? S. अगर फर्स्ट 100 नेचुरल नंबर्स का सम S है, तो मैं इस तरह से लिख सकता हूं दैट S इज इक्वल टू 1 plus 2 plus 3 plus 4 plus 5 plus and so on till 96 plus 97 plus 98 plus 99 plus 100. तो मैं इस तरह से लिख सकता हूं. अगर शुरू के 100 नेचुरल नंबर्स का सम S है, तो मैं लिख सकता हूं S किसके बराबर है? इसके बराबर. ओके, ये चीज हमने लिख ली. अब उन्होंने एडिशन नहीं किया, उन्होंने इन सबको ऐड नहीं किया कि 1 plus 2 plus 3 plus 4 ऐसा करते जा रहे हैं, ऐसा नहीं किया. उन्होंने यहां पर एक थॉट लगाया, एक प्रेजेंस ऑफ माइंड दिखाया. उन्होंने इस अरेंजमेंट को रिवर्स कर दिया. रिवर्स कर दिया मतलब उन्होंने S को एज इट इज ही लिखा, S इज इक्वल टू, अब ये जो मैंने एडिशन लिखा है 1 से लेके 100 तक, तो आप ये जानते हैं कि A plus B और B plus A ये दोनों चीजें बराबर होती हैं. A को B में जोड़ दूं या B को A में जोड़ दूं, दिस इज वन एंड द सेम थिंग. ओके, ये बिल्कुल सेम होता है. ओके, सो गॉस ने लिखा कि अगर S इसके बराबर है, तो S 100 plus 99 plus 98 plus 96 plus 97 plus this is 1 2 3 4 5, then this is 5 plus 4 plus 3, oh sorry I have written it, this is 97 and this is 96 and this is 5 4 3 2 plus 1. तो मैं इस सम को ऐसा भी लिख सकता हूं, क्या करा, जस्ट इस 1 to 100 जो लिखा था इसको रिवर्स कर दिया, तो ये चीज आ गई. ओके, देन ही सेड दैट लेट अस से दिस इज द फर्स्ट इक्वेशन, दिस इज द सेकंड इक्वेशन. इसको मैंने फर्स्ट इक्वेशन माना, इसको सेकंड माना, फिर एड 1 and 2, simply add the two equations, s is equals to ये, s is equals to ये. Now think what will happen if I add these two equation, what will come in LHS. LHS, here it is s, in this equation LHS there is also s, so s plus s, this is s plus s, it will give you 2s. okay, s plus s is equals to 2s is equal to 1 plus 100, that is 101, 2 plus 99, that is 101, 3 plus 98, it is 101, 4 plus 97, it is 101, 5 plus 96, it is again 101, and plus so on. 96 plus 5, it is 101, 97 plus 4, it is 101, 98 plus 3, again 101, 99 plus 2, again 101, and 100 plus 1, again 101. So now try to understand the conclusion, try to understand the concept. मैंने इस नेचुरल नंबर्स के अरेंजमेंट को घुमा के लिख दिया और फिर दोनों को ऐड कर दिया, तो मुझे दिख रहा है फर्स्ट टर्म और लास्ट टर्म, इस फर्स्ट को और इसके फर्स्ट को, मतलब दिस इज एन एपी और ये है रिवर्स ऑफ एन एपी. हमने कॉन्सेप्ट पढ़ा था रिवर्स ऑफ एन एपी का. तो फर्स्ट टर्म और इसके लास्ट टर्म को, दैट इज 100 को ऐड करा तो ये आया. फिर सेकेंड टर्म को और सेकेंड लास्ट टर्म को ऐड करके ये आया. थर्ड टर्म थर्ड लास्ट टर्म, फोर्थ टर्म फोर्थ लास्ट टर्म, फिफ्थ टर्म फिफ्थ लास्ट टर्म, एंड सो ऑन. सो व्हाट यू कैन सी, every time if I add these two terms it will give you 101 101 101 and so on. अब ये सोच के बताइए ये 101 कितनी बार आया होगा, कितनी बार आया होगा. This 101 will come the number of times equal to number of terms in this series. जितने terms इस series में होंगे, इस arrangement में होंगे, उतनी ही बार 101 आ रहा होगा. तो just try to think, इस अरेंजमेंट में कितने टर्म्स हैं, इस अरेंजमेंट में कितने नंबर्स आ रहे हैं, कितने नंबर्स की लिस्ट है ये 1 से लेके 100 तक. इट मींस 100 टर्म्स. ओके, 100 टर्म्स है. अब अगर मैंने इस अरेंजमेंट को रिवर्स कर दिया तो ये चीज आ गई. इसमें कितने टर्म्स हैं, इसमें भी होंगे 100 टर्म्स. तो अगर मैं इसके फर्स्ट टर्म को इसके फर्स्ट टर्म में ऐड करता हूं तो 101 आता है. ऐसा करते करते इसके लास्ट टर्म और इसके लास्ट टर्म को ऐड करता हूं तो भी 101 आता है. तो 101 कितनी बार अकर हो रहा है, आई विल से 101 विल अकर 100 टाइम्स. ओके, आई विल से 101 विल अकर 100 टाइम्स. 100 बार आपको 101 इस सीरीज में दिखाई देगा, बिकॉज 100 टर्म्स ऐड हो रहे हैं. ओके, इसके 100 टर्म्स इसके 100 टर्म्स में ऐड हो रहे हैं, तो टोटल 100 बार 100 नए टर्म्स बन रहे हैं. ओके, सो कैन आई राइट इट एज 2s इज इक्वल्स टू 101 into 100, because 101 is occurring 100 times, so I can write 101 into 100. Simple concept. If you have 7 plus 7 plus 7 plus 7, so you are adding 7 4 times, it means you are simply multiplying 7 and 4. So this is the same concept I have applied here also. 100 times मैंने 101 को लिखा, मतलब 100 से उसको मल्टीप्लाई कर दिया. तो यहां से s का वैल्यू कितना आ जाएगा, 101 into 100 upon 2. So when you solve this, it will give you 50, and the value of S obtained is 5050, and this S represents sum of first 100 terms, or first sum of first 100 natural numbers. So try to compare the normal calculation and this method that Gauss have applied. You can see the calculation in this method is negligible. A very basic calculation of adding 1 and 100 only. Okay, and you will get this answer. So just think, in how many seconds you can solve this? You can solve this within 4 to 5 seconds. Okay, 4 से 5 सेकेंड का ही समय लगेगा. जस्ट अगर हम सोच लें 101 और 100 ऐड हो रहे हैं तो, सॉरी 1 और 100 ऐड हो रहे हैं तो 101 बनता है, 100 बार लिखा है तो डायरेक्टली 2 से डिवाइड करा, एंड 4 to 5 सेकेंड्स और मे बी 10 सेकेंड्स में आप इसका आंसर निकाल सकते हैं. ओके, सो इन दिस मैनर यू नीड टू सॉल्व this particular sum of first 100 natural numbers. Now just think of it, if we apply this concept in arithmetic progression, I can calculate the sum of any number of terms in an arithmetic progression. Okay, we will discuss that concept. We will derive a formula to calculate the sum of 1000 terms, 100 terms or n terms of an AP. Okay, so this is the concept that Gauss have applied in when he was just 10 years old. So just think about his IQ, think about his intelligence कि वो कितने ज़्यादा intelligent थे. Okay, so you can note this, then we will continue, we will derive the formula.